Good afternoon. We are continuing with this topic, renewable energy integration. So, here in this slide you can see that what is the fuel share in power sector. So, this graph shows this power, how power is being generated using through various fuel sources. So, graph showing from year 2000 until 240. So, here in this graph you can see that share of coal is decreasing because of the obvious reason of this emission being caused because of this coal power generation. Then this blue line you can see for the large hydro and nuclear. So, this also you can see slight bit trend will be in decreasing because most of the large hydro power plants have already been harnessed, and some countries are not in the favor of nuclear power generation. Then use of gas is almost consistent. Gas is not as problematic as we have coal or oil for electricity generation. We have other use of gas as well for cooking purpose, and now we can see the gas being used. Previously we used to have the cylinder in the homes, but now gas pipelines coming to the homes. So, basically gas does not cause that much of pollution what it is being done by the coal or oil. The great interest is now the electricity generation through small scale renewables. So, if we see the current trend for the renewable power generation, although we have been talking too much about the renewables, but the current share worldwide is something around 15%. Okay. Of course, here we are talking about the small scale renewable power generation. We are not talking about the large hydro power plants. Of course, if we include the large hydro, then this share will be obviously significant. Large hydro is obviously also the clean source of electricity generation. Of course, it has some issue, big dams have to be constructed, some ecological imbalance can be there, but otherwise large hydro is also renewable based generation. So, now worldwide the current trend is generation of electricity through renewable distributed generation. If you see the previous approach, how we used to generate electricity through larger generating units, mainly through this conventional power plant, coal based, nuclear, large hydro power plants. So, economy to this scale is there. I will give another small example. If you buy 2 liter of Coke, how much it will cost, or if you buy say 200 ml. So, obviously 2 liter will be cheaper. Economy to the scale is there. Same principle applies almost everywhere. But if you see that for the generation of electricity, one approach is to have the largest generator. Of course, in the past that used to be more economical, but in the current scenario, if we are generating electricity through the small size generators, could be photovoltaics, so or some other type of generations. So, even this could be less expensive. Reason being that these small scale generators are very close to the load center. we have these, like here we are consuming the load, our PV generator could be just on the rooftop. So, practically distance is negligible. If we say distance few meters or 1 kilometer, 2 kilometer, it is obviously negligible when we are talking about the distance of 1000 kilometers for the large power plants. And as we know that the power losses, transmission losses, distribution losses basically depends upon the I square R resistance, which is proportional to the length of the line. So, this one of the great benefits what we have from this renewable distributed generation is that the grid losses are significantly reduced. Another great benefit we see that these renewables being the green technology, they offer the positive impact on the environment. One of my PhD student wrote very nice research paper on this integrating renewable distributed generation, a review paper published in IET RPG. So, he has very nicely documented a review for the renewable distributed generation. But when we are using this renewable power generation, there are several challenges. Some of the challenges are listed here. Generally, these renewables are highly fluctuating and intermittent in nature. If you talk about the wind can fluctuate plus minus 25% in few minutes. You have very high wind blowing, after some time no wind at all, no electricity generation. Okay, wind is highly fluctuating. Talk about the sunshine, during night no sunshine, during the day anytime clouds can come. So, they are highly fluctuating, intermittent in nature. Although we are talking about this renewable and clean source of electricity generation, but if you talk from the electrical engineering point of view, when we want to generate the electricity, even we call the coal based generation for example, which is most dirty, causing so much of pollution. But from the electrical perspective, electrical point of view, we want to see the stability of the system. Okay. So, if a coal stockage, electricity being generated, voltage frequency in the control system is very much stabilized. Okay. No major issue. So, from electrical point of view, coal based generation very clean. When you are saying clean, system is stabilized, not problematic. But when we talk about the renewables, we say sustainable, but it is most problematic. If you have wind power system, there is no wind. Okay. If we have the solar, very clean, but no sunshine. Okay. So, if you say we have solar, but there is no sunshine, okay. So, not much use. Okay. So, from that perspective, you can see from the operational point of view. Okay. So, there are so many operational challenges. Okay. If you see conventional power system, the generation is quite stabilized. You have the reserve for the coal, power produced stable, no major issue. A little bit changes on the load side. But if you have renewable power generation, the load is on the mood of the customers, generation on the mood of the weather. Okay. So, too much uncertainty. Okay. So, from that perspective, like this renewable power system is most dirty, most problematic, right. Of course, it is very sustainable. The way I am presenting, I am trying to, what does it means that for the operational point of view, things becomes very complex, very challenging. So, fluctuating and intermittent in nature, and you see another issues like when you want to tap the renewable power generation. So, you have to create the infrastructure, construct the transmission line, make the infrastructure ready for that. And then another issue you see that when we are interconnecting renewable power generation to the grid, because of use of these power electronic converters, power flow becomes bidirectional. You can feed power into the grid, you can draw power from the grid. So, power flow becomes bidirectional. So, because of this power flow becomes bidirectional, whatever the protection scheme which we have been using in the power system, we use the less costly protection scheme using the one directional relay, because the current direction is one, mainly from the generation through transmission to the distribution. But when the power flow becomes bidirectional by use of the renewables, now current can flow in any direction. Current can flow from the consumers to the generation side. So, current direction is bidirectional. So, the existing protection scheme may not work well, protection scheme may need to be significantly modified. So, specific attention has to be given for the protection scheme. So, sometime like for example, if some maintenance is being done, we may think that through the circuit breaker you have made switch off power from the utility side, okay, and operators are working. If this PV is connected, so it can also cause the electric shock. Okay. So, one has to be more careful about the protection scheme. Then you can see that if these distributed generations are decided based on the appropriate simulation studies, here it comes the role of these researchers, that the renewable distributed generations location and sizing. It cannot be just like say you decide okay you have this much size you place here and there, but if you really want to get the appropriate benefits, then optimum location and sizing has to be decided through the proper simulation study. So, for that the role of the power engineers conducting the simulation study becomes very much essential. Some people can say what simulation you are doing without hard work, so it is of no use. Okay. If simulation study is properly conducted with proper meaning, so generally it will give you the results very close to the hardware. Creating of the hardware for each and everything is not possible and feasible. I was listening one of the lecture by this the Dig Silent Power Factory guy. If you see that what is the most complex system on the earth, it will be electrical power system. you will see how many loads are connected, millions or billions bulbs, right? How much transmission lines are there? Okay. If just like say ant, you have one bulb and you start traveling through the wire, you can reach up to this Delhi power plant or wherever you can go, right? Everything is connected. Thousands of devices, lakhs of devices, you know. So, it is the most complex system. Everything you cannot make the prototype or hardware. Do you agree? So, the simulation study becomes extremely important in the electrical power system. So, because of the nature of discipline, it becomes very much essential that whatever simulation study we conduct, it is extremely important. It is not that we academicians do only the simulation studies. You may think that industries might be doing something ground breaking hardware stuff. Okay. I previously worked for my sabbatical when I was at the University of Queensland. I had opportunity for 6 months to work in the Queensland transmission company. Okay. So, Queensland, big state, I think more than 1500 kilometers, okay, in the length, okay, 1500 kilometer, very, you know, Australia very big area wise. So, that company, like most of the company, transmission company, all what they do, just do the simulation study. Although it is company, you may think that all people will be doing hardware, but almost whole study doing through the simulation study. Whatever the software we are using, MATLAB, PSCAD, PSSC, Digisilent, Power Factory, all these things are being used. Whatever the researchers will be doing, same way they are doing. Okay. So, the point what I am trying to say is, if you are doing simulation study, do not underestimate yourself. Do you agree? So, someone say what you are doing, you are just doing simulation study, no hardware, it is meaningless, right. So, you have to justify some way. The point little bit I try to explain. You have to give the importance what you are doing. But if you are doing it a proper and meaningful study, meaningful analysis. Okay. So, the programs are very nicely designed, okay, designed by, you know, whatever the software program is there, MATLAB is there, Digisilent is there. So, hundreds of engineers work on that. Do you agree? That there will be hundreds of engineers who will design this program. Whatever best way the program is designed, and then whatever parameter you give input. Okay. The program is nicely designed, but if you program the input wrongly, if you feed the parameter incorrect, so what will be the output? Output will be wrong, right. So, that guy who was giving the training on the software, Digisilent, he says garbage in, garbage out. If you give the wrong input, program could be very nice, but the output will be wrong. So, basically again whatever program you are using, whatever parameters you are selecting, how the parameters we are tuning, it has to have some scientific and some meaningful. Whatever the simulation, whatever research we are conducting, the analysis, the software can give you the output, how you are going to analyze. So, here it comes the analytical skill, very important. Okay. So, how you analyze. So, these are the some of the challenges. Challenges are very much significant, so much uncertainty, it is not very favorable, but the point what I mentioned, the issue of emission is really a big problem. So, there is no rethinking or alternative. Worldwide, the approach is to move towards the sustainable means of the electricity generation, okay, although being so many challenges. So, this the optimum and significant studies are being conducted. If whatever the research being done in electric power engineering, power area, whether you call it India, whether you call it US or anywhere, right. So, things are mostly around the microgrid. Many of you might be doing, so if you ask a topic, most of the topic will be around microgrid. Do you agree? Even I have not asked anyone's topic, right? But by default at least 70% close around this, okay. So, this is the current trend for the this generation, okay. So, here like the optimum location sizing, reduction of the losses and so on is extremely important. In this paper, although we talk the two benefits, reduction of grid losses and being green technology, but that my that PhD student, his writing skills are excellent, okay. So, same thing you say like in 1 or 2 points, same thing how you document very nicely, right. So, he listed down so many benefits so nicely, like say renewable power generation can improve the reliability, it can improve the voltage profile, obviously it can reduce the losses, security enhancement, operational advantages, economic benefits, environmental benefits, okay. So, when you are doing literature review, your study, so you are welcome to study it in more detail. Because of time constraint, I cannot go into more detail, but please you can stay in touch if you need any discussion, if you need any more information. So, you are welcome to contact me later as well, okay. So, when we classify this distributed generation, whatever we call like the microgrid, in microgrid main thing what we are, of course microgrid is a system, here we are talking about the distributed generation, but distributed generation also becomes obviously in electrical engineering we are not talking about only generator, we are talking about the system, okay. So, system will have obviously generation and the load and some other components as well. So, here this distributed generation you can classify as the renewables and non-renewables. Renewables, as you know, wind, PV, geothermals, small, mini, micro, hydro, biomass, fuel cells, and several renewables are there. Then non-renewables in terms of like the, you can call diesel generators, turbine, gas turbine, micro turbine. So, there are different these diesel distributed generation generator technology. Then in some of the literature you will see that obviously we would like to compare different technical and other aspects to compare the performance of say different distributed generation technology. It could be renewables, it could be non-renewables, So, some of the comparison factors could be in terms of generally this distributed generation, what capacity, what size normally they are available, how much is the efficiency, how much is the efficiency of these different sources of generation, what type of fuel is used, how much is the emission coming out from the different types of generators, renewables, non-renewables, so that you can, and you can list maybe some more cost and so many other factors just to make the comparison and see what appears to be the say best or nice type of generation. Okay. So, here the first it lists down this you see non-renewables, this side renewables. First is talks about this in general what could be the capacity, size. I am not going into the detail, it is self-explanatory and you can find in several researches, it is not only one paper. Then in general you have the idea about the efficiency, not very exactly, but at least general range you have the idea. So, here diesel generator efficiency something around roughly 40%. Okay. Then you should be aware the efficiency for various types of generation. Then of course, the type of fuel used. Another great benefits, although being so much problematic renewables, other great benefits generally with the renewables like the wind and solar is that no fuel is used or fuel is free from the load. Wind freely available, no cost, no tax, right. Sunshine free. So, no tax, no cost, right. But if you talk about the diesel, you talk about the coal, we have to burn too much of sensibly. Okay. If you have to burn, we have to burn, but burn not because of the wasting. That Professor Rao was what he was mentioning, one way you are using the coal or diesel, using the electricity. So, whatever pollution is being done, it might be acceptable, but not, for example, you have the car, okay, you are using it, even it is causing the pollution, not a big problem. But if you just start the engine and car is stopped, what do you think? Long back I used to stay in Fiji island, you know, then one of the neighbor there, you will just start the car and leave it on for 1 or 2 hours. I used to ask my wife what he is doing. Then somehow she tried to get an idea that he wants to get the claim from the office. So, the point what I am trying to say that even if this emission is being caused, at least something useful is being done, you can justify. So, but for the wastage, if we are, you know, we know all these whether coal, gas, anything is being used, if it is serving some purpose, it is acceptable, even it is causing pollution. But if you have this, you know, like say car, as I give example, you just start the engine and keep it running for 6 hours. So, you cannot justify by any means, except if you have to claim from office. I am trying to make little bit, you know, joke to make you class not very boring. So, then you can see that the emission what is being caused from the different types of generation. We talked about the like say non-renewables. like the diesel generator. Okay. So, how much emission is causing? I am not reading these figures. Okay. You can do it your own, but here clearly you can see from the wind and PV. Wind and PV, how much is the emission? Almost no emission. Everyone agrees? Okay. So, this is these two greatest advantages in the favor of renewables. Almost no running cost, no fuel, okay, no emission. Like if we have PV panels, does it consume oil? Does it consume coal? No. So, this way they are the best. Okay. Although there are some other challenges, but these are the great benefits in the favor of renewables. Even it can have low efficiency. Okay. We say PV efficiency generally around 15%. Okay. PV efficiency around 15%, coal efficiency 40%. Okay. So, even PV low efficiency, it is a concern. If it has better efficiency, we can get more power, but still if the efficiency is low, it is not as big concern as we have for the coal, because coal, you are burning coal, you are burning money, but here we have the sunshine which is free from the nature. Okay. So, even the efficiency is low, it is not as big concern as we will have for the coal or oil or the diesel based power plants. Now, let us talk about the distributed generation interconnection requirements. Okay. When we have these renewables, we cannot just connect it. We need to follow some standard procedure. Even if you have to connect any equipment, first we will read through the manual. Okay. So, before connecting to the grid, if you have any equipment, first of all we will try to read its manual, and then we will try to. Nowadays, if you have any stuff you are bringing from market, then how you assemble anything, how you connect, obviously we need to refer some manuals. Without manual, nowadays very difficult task to do anything. Okay. So, this grid connection interconnection requirement, there is one standard IEEE 1547. So, this is for the small scale renewable integration standard. So, this standard lists down large number of interconnection requirements. Some of the important ones I have listed down in terms of like the fault ride through capability, voltage and frequency operating limits, active power control, reactive power control, other requirements in terms of power, quality and protection. So, this is like a big document standard. Okay. If I start talking in detail, I can speak on this slide for 2 hours. Okay. But we have time constraints, so I will not go into that much of detail. So, fault ride through capability means what? That if the fault occurs on this power system, renewable power system, how the power system should respond. Okay. So, in past, when our control systems were not very robust, when fault will occur, we would like to protect our renewable power system. When fault is there, so we will disconnect the renewable power plants from the grid. We want to protect our renewable power system. Okay. But now with the development of technology, the renewable power plants will not be immediately disconnected, but they will stay on the power system as far as applicable. They will not only stay connected, but they will try to help in recovering of the fault. Okay. If the renewables are immediately disconnected, in that case the gap between the generation and demand will increase, because renewables are also supplying the electricity. If because of fault you switch off the renewables, then how the demand will be met? The gap between the generation and demand will increase. So in that case, in modern trend, renewables are not immediately disconnect, but they try to help in recovering of faults. For example, when the fault occurs on the power system, generally voltage will go down. Okay, in between you can also ask question, or maybe at later you can ask if you have any queries or doubt. So when there is fault, generally voltage will go very down. Then these renewable power plants, how they can support for the voltage? They can provide the reactive power. So when reactive power support is there, it can try to help in boosting of the voltage level. So there are several ways when the fault occurs, these renewable power plants can help in recovering of the fault conditions. Talking about the voltage and frequency operating limits. So here you can see these two graphs. Upper one is for the Denmark, below one is for China, and you can see that on the x axis frequency, on y axis voltage. As you will see that in power system we have to maintain the voltage within plus minus 10% variation in transmission, or in distribution plus minus 5%. Okay, the voltage regulation. The frequency in case of Denmark, you can see that nominal frequency operations should be between 49 to 51 hertz. If the frequency deviates outside this range, then we have to bring the system back to the nominal operation. We cannot afford to have the frequency 47 or 45 hertz. At 45 hertz, everywhere it will be blackout. Okay. So in the interconnected system, we have to maintain the frequency. And of course, within this, the frequency we have to maintain within the specified period of time. If our control system takes more time, then our system will become sluggish, our power system can become unstable. When we are doing any analysis, we will see that this response settles how fast. If it takes too much of time, then our controller is sluggish one. So this is one of the very important parameter to see about the controller behavior. Controller should respond very prompt. Then interestingly, you can see for the case of China, generally we will see that China products are poor quality, right, in most of the cases. But it is not the case. They will see where the goods to be dumped. If it is to be dumped in the developing or underdeveloping countries, it will be poor quality. If the goods is to be supplied US, it will be very top quality. So they will do the things intelligently. Okay. So, sometime I talk little bit lightly, it does not mean I am criticizing something, but to just make it little bit interesting. So, you see when you have any food, little bit added flavor is permitted. You have seen some products, it will be written little bit, of course it could be little bit bad for health, but say little bit added flavor, little bit color, little bit taste added, because to make it little bit interesting. Otherwise you get bored and then everything is not good, right? So, the point what I am trying to say here, that in case of China, you will see this normal frequency operation, it is between 49.5 to 50.2 hertz. Can you see in the graph? 49.5 to 52 hertz. So, this normal operation bandwidth is very narrow here in case of China. You can see my cursor, please. You can see my cursor, and here it is quite wide. So, and if the frequency deviates outside this range, so you have to bring the system back to the normal operation. The point what I am trying to explain, generally we have thinking that if we connect this renewable power system, it will affect the quality of supply. This is the common thinking many people will have. Not only the people, some countries can have this thinking. I worked previously in South Africa. There is one company, Eskom, which generates, transmits and distribute electricity. There is deregulation has not occurred like what we have here 20 years earlier. What we used to have, same electricity board for generation, transmission and distribution, but now you see GENCO, Transco and DISCO. Have you seen that? So, deregulation has occurred, because for one company it is very difficult to manage transmission, generation, distribution, because this is too much work, right. So, that company thinks, because their main business is they want to have their monopoly. Okay. If they want to, someone want to have monopoly, they would not like any suggestion whether good or bad, right. So, what they will little bit think that renewable is a problem, right. They say it will affect the quality, but here you can see that it is not the exact case, because how you design, how you implement the guidelines, grid codes, accordingly quality will be there. If you tighten the grid codes, okay, so generally this renewables supplied by the IPPs. IPPs means independent power producers, small scale power producers, private companies. Whatever the guidelines, how you float the tender, if you tighten the technical bids requirement, so these independent power producers which are not qualitative one, they will not able to meet the technical requirements. So, they will be screened out. Only the qualitative independent power producers are there, they can only meet these technical bid requirements. Are you following? Are you following what I am saying? That if you have the poor quality suppliers, they will not able to meet these technical requirements. So, they will not get successful in getting these bids requirements, because they cannot meet these technical requirements. When we have any tendering process, one part is the technical one. So, here you have to meet the technical requirement. If some company or supplier cannot meet the technical requirement, even is economical, so you will be out. First thing is that the technical requirements should be met. If technical requirement is not met, so bid will be not opened, it will be disqualified, because that does not meet the requirement. The tenders which meet the requirement, then only technical economical comparison will be done. So, the designing and implementing the grid codes, the rules, regulations, if you tighten, then it can not only maintain the power quality, but it can improve the power quality as well. Like how this power quality can be improved, for example, you have these photovoltaic systems, okay, and with the photovoltaics you have the converters. Initially these PV panels will operate at unity power factor. Okay. Unity power factor means reactive power supplied will be 0, because power factor is 1 and Q will be 0. Okay. But now basically we expect that this power system should able to operate with leading or lagging power factor. What does it mean? That they can, through these converters, they can supply reactive power to the grid. Supplying the reactive power to the grid means that they can support for the voltage. Okay. So, by having these renewables, even they can improve the power quality as well. Okay. So, this I talked to you about the voltage and frequency operating limits. Now, talk about these, like say active power control. We are talking about the set point, ramp rate, reserve, frequency regulations, because these renewable power plants we operate along with conventional power plant, right. So, how much renewable power generation will be there for the next day? It will depend upon the weather condition, how much will be the sunshine, how much will be the wind, for example. So, it depends upon how accurately forecasting is done. Okay. But the customer needs the power with certainty. Okay. Customer is paying, so he expects to have the power 24/7/365 without fail. Okay. Whatever weather is there, if weather is bad, they need more power, right. So, this is not their botheration, this is like their basic right to get the electricity. Okay. So, the utilities, coal based generation companies, they have to generate the electricity, they have to keep their plant in the hot condition. Okay. Means that they have to keep their boiler in the hot condition. They cannot have this like the just switch, you started the boiler, it will start producing the power at the same time. If you have the this boiler in the stop condition, if you have to start, it will take around 8 hours for the power to start generating. So, basically and if you are keeping the plant in the hot conditions, it means you have to keep on burning the coal. Okay. So, this ramp rate, then if you have the plant, different types of power plants are there, coal based power plant, gas based power plant. Ramp rate, what is the ramp rate, or the speed at which load can be taken, like say 100 megawatt per minute, how much load it can pick up. Okay. Like the, say for example, the youngster, new bike, stopped on the red light, how fast they can have just ramp rate. So, race cars, for example, race car, if ramp rate or the speed is slow, no use. So, you have to see the ramp rate. The loads comes on the power system, it does not wait for a minute, right. If the load is sudden, 100 megawatt came, so it will not wait for the coal based power plant to start from the coal, or the coal based power plant, the ramp rate is not that good. Gas based can be quick start and quick ramp. So, why this is I am discussing talking, because you have to maintain the generation and demand in the real time within seconds or milliseconds, otherwise frequency deviation will be there. So, all these issue, ramp rate, reserve, frequency regulations, particularly in the deregulated environment, electricity market environment, this becomes extremely important. When you have electricity market, pricing keeps on changing, as we have share market, a price keeps on changing every hour or every half an hour. Then you know how this demand is increasing, so the prices are very much dynamic. So, all this becomes like the ancillary services. Then talking about the same way, reactive power control, very important, reactive power control to maintain the voltage in the power system. There are other requirements in terms of power quality, protection, etc. So, this I briefly talked. As I said, I can keep on speaking 2 hours more, but we have the time constraint, but I try to explain as best I could speak in few minutes of time. Now, let us see little bit not only the microgrid, talk about the renewable power generation. We integrate the renewables, whether whatever quantity, small or big, whatever we add, we are doing very well. Okay. So, let us see little bit overview of the what is the status of the main renewable technology. The commonly used, commercially successful renewable technology at this stage are the wind and photovoltaics. Wind both onshore and offshore. Worldwide, at the end of 23, the installed capacity worldwide, it was around 950 gigawatt by end of 2023. The countries which are leader in the power generation from the wind are of course China, US. Few years earlier, US used to be the leader, but you see how fast China is expanding, then Germany, and then of course our country doing very well. Okay. So, then talking about the offshore, the wind turbine inside the sea, offshore. So, this power generation from the offshore is relatively new technology. So, it is more costly. Okay. Offshore, you few years earlier you hardly used to see any research paper on the offshore, because it is more costly, but now at least when you, if someone doing on the wind power system, you can see now research started as well. It is costly, comparatively more costly, but as there is more and more capacity addition, cost will come down. So, for the offshore global wind capacity by the end of 2023, it is 75 gigawatt. Okay. So, total capacity you can see from the wind maybe around 1000 gigawatt. Okay. If you see by end of this, how much is the capacity addition every year? What is the growth rate for the wind every year? So, it is around 10%. Okay. If now the global wind capacity is 1000, next year it can increase around 10%, it can go 1100. I am talking approximately. Okay. So, the growth rate in case of wind is around 10%. We will also see how much fast this solar is expanding. Okay. So, here if you see the situation maybe 2 years earlier, if you see the situation 2 years earlier, China would have been nowhere in the offshore. Mainly power generation was in the part of the Europe. But now you can see the China is also world leader in case of the power generation from the offshore. As this technology matures, we may expect soon in the future that several countries are coming forward for the electricity generation from the offshore, because you will see many countries they have the nearby sea and coastal areas, and obviously you will see that most of the good or big cities are close to the coastal areas. Okay. Like in Australia, all these cities, even most of the population on the coastal areas, inside almost blank. So, what I am trying to mention, that load is generally close to the generation. Okay. So, that way the development cost for the offshore can be reduced, and in coming few years, so the offshore could emerge as the another great way of electricity generation. Okay. So, as we are talking the renewables does not mean that only we are talking about the microgrid few kilowatt, but now these renewables are developing like as we have the conventional power plants. Some of the example you can see in China, the wind power plant for 20 gigawatt capacity. In our country, we have this wind park of 1.6 gigawatt. Then like in other countries like the USA, in our country Tamil Nadu state, which has significant power generation from the wind, another large size wind farm of 1.5 gigawatt. And so the point what I am trying to say, that these renewables are now being developed not like the micro grid level, but they are like these, as we have the conventional power plants based on the coal, gas, nuclear, etc., large size power plant. So, they are also getting developed for the very big capacity. Okay. So, how this the forecast from the wind it could be there, current installed capacity what you have from the wind both onshore and offshore, around 1000 gigawatt as you have seen in the previous slide. Okay. So, how much we can expect by 2050, say next 25 years. So, based on the different projections, current installed capacity around 1000 gigawatt. So, what we can expect by next 25 years, it could be say 4 to 6000 gigawatt, means 4 to 6 times of the capacity what we have. The growth rate, how these wind power plants are expanding, growth rate is around 10% every year. Okay. So, within a period of 10 years, the capacity will double. Like we have say 1000 gigawatt now, within say around 10 years, it will become 2000. Mainly the expansion is on the onshore. Offshore is slow because it is more costly. Maybe in few years it also becomes less costly, then it can suddenly start expanding. Okay. So, the wind we can see the growth this way. Now, this slide very interesting. Anyone have seen this graph in any research paper? No? So, this you will see that is coming from this paper published in Electric Power Components and System. Are you aware of this journal? Have you heard this name? Electric Power Components and System? Yes, Taylor and Francis, right? So, this shows that how the development in the wind turbine technology has taken place, how the size of the wind turbine has increased with the corresponding rotor diameter, what is the role of power electronics, what type of generator technology is used. So, this slide very nicely designed by the researchers, very good. Okay. So, here you will see that around 1980s the size of wind turbine used to be around 50 kilowatt, the wind turbine diameter around 15 meters. Okay. Then as we progressed, say reach around 95, the wind turbine size increased to 1000 kilowatt and 1000 kilowatt and the rotor diameter around 50 meter. Okay. This paper written by great researchers, very big researchers. Anyone recognize or anyone come through any name? No, you are the this used to be the editor in chief for this component journal. This is another big person in the power electronics. Anyone doing research in the power electronics? So, is the very big name. Okay. So, they are the big researchers. The point what I am trying to tell is that when we are writing research papers, generally research paper will be written by young researchers, PhDs and postdoc. Hardly any professor will be writing paper. Okay. So, you will see that in a paper generally 3, 4, 5 co-authors will be there, but it becomes the responsibility for everyone, whether post PhD student or professor, to ensure that everything is good, right. This is very important, because if any mistake is there, so professor will shout on the student, you did not read it carefully, right. So I am trying to make it little bit lighter. Okay. So here even in this big team, you can see that here I overwrite, it was 100 kilowatt. Okay. So when you are co-author, it doesn't mean that you just check your name spell and don't see anything else. When if you have anything, first thing we will see that let me check my name, all spelling correct, my affiliation correct, rest go with the hell, other person will see that, right. So it is not good approach, okay, because you are the co-author. If you get any award, you will be the first to receive, but if you get any criticism, you have to bear as well. Yes or no? Okay. So it is very important. Of course, there would be time constraint, because you young researcher, you have only one dedicated work. Okay. But professor might be supervising 5 PhD at the same time, teaching so many institute work, director is calling, head of the department calling, he has multiple activities. Okay. So the researcher has got dedicated time. First it comes to the researcher that try to put his or her best effort. It is not only that how many paper you publish, okay, but it is very important that you publish little bit less, but whatever you publish, there can be some human error left, okay, not a problem, but any error generally should not be picked up by anyone casual reader. Are you following? Okay. I give you another example. For this paper or similar paper, again written by big author. So review paper containing hundreds of reference. Generally, if your review paper, it will have around 100 reference, right? If your review paper, you will see that references are around 100. Right? So like say, what software you use for these references? Arranging references, you use any software, automated one, Mendeley or something like that? Okay. So it will arrange you whatever format. I am just testing my knowledge as well, I never used that, but still I heard from some student, Mendeley. Okay. How you arrange this reference, maybe elsewhere style, okay, or maybe IEEE style, it will do for you very quick, right? Yes, no? Okay. So that way it is very good. The point what I am trying to say, it cannot replace the human being. Okay. Why I am trying to say, because you know, if you have this 100 reference, if by the way some reference got repeated 2 times or 3 times, can Mendeley tell that this reference is repeated? Yes, no? It will tell that this reference is repeated, that this reference is repeated again. It will point out or no? I think no. Huh? It will detect. But I see that many papers, I don't know what they see, sometime same reference being repeated 2 times, 3 times. Even whatever software you use, it will not give you the perfect. Sometime in same reference, year is appearing 2 times, 3 times. Okay. Year is year like 24, why it is coming like 3 times in same reference, particularly in the conference. Okay. So, it will not have the means the uniform formatting, the manual intervention becomes still important. Okay. The point what I am trying to say, that you cannot completely just say that software has done, my job is over. Okay. I give you another example. Long back when I was in BITS Pilani, we will print the exam paper for the student, okay, and then we distribute the paper. If there is any printing mistake left or printer did not print well, so one lecturer say that printer did not print well, printer did not read this font. I said that you cannot blame this poor guy printer, you have to have the responsibility, right. So, it becomes our job to check what is printed, what is not printed correctly, because printer is non-living thing, you cannot blame the printer, can you? So, basically you know, cross check in the loop is extremely important. Okay. Like for example, you publish, young researcher, you wrote the paper, okay, you give it to the professor, and if you notice few errors, he will criticize you. So, first thing is that please read it carefully. Okay. So, this proofreading, all these things, when you can do lot of realistic research, all these editing work needs some time, needs some patience, but it is very much essential, because publishing is not a problem, criticism can start after publishing. If the people will obviously read, the researchers will read paper, and then they will, you know, obviously review paper, read it, how nicely written. So, whatever good name or bad name comes will come from there, right. So, it is very important that whatever we publish, you know, we do it more sensibly. Okay. So, then this the size of the wind turbine kept on growing. Year 2000, the size of the wind turbine went to 2 megawatt, with the size of the rotor blades, wind turbine rotor blades, gone to 80 meter in diameter, and there was a breakthrough in the generator technology. Previously, we had been using induction generator, as you know, induction generator based on the two types of rotor, squirrel cage and slip ring, okay, wound rotor. So, initially we used the squirrel cage, which is more robust in construction. Then we started using the slip ring as well. In slip ring you can add the external resistance. Here we started using the generator DFIG. Everyone knows DFIG, doubly fed induction generator. So, here you can see the role of power electronics becomes significant, around 30% rating of the power electronic converters. Okay. So, great advantage of this generator is that it can supply power both from the stator as well as from the rotor terminals. Okay. Thereafter again you see size of the wind turbine kept on increasing, corresponding diameter kept on increasing. There is another great generator technology, what we call as the PMSG. What PMSG stand for? Permanent, excellent, permanent magnet synchronous generator. You will see in one of the research paper, this one, power electronics drives controls electric generators. So you will find very nice documentation of this power electronics generator. So very nicely documented. Okay. So here you will see that in the development of the generator technology, in the progress of the wind turbine technology, how important is the role of this power electronics. Can you see the role of power electronics, how important it is? Okay. Now this is another very recent slide. I just updated. You can see this report year 2024. Okay. So here this slide gives you the size of the wind turbine both for the onshore and the offshore. So let us see first below one, offshore. This is from the report GWEC report, Global Wind report to 2024. So here how the size of the wind turbine keeps on increasing. So what is the size of the wind turbine, what we expect? Currently the size of the onshore is around 10 megawatt. Okay. Please little bit read this slide because I think there will be quiz as well. Okay. I will not be giving the quiz will be given by here local one, but please keep little bit idea about all these figures. Then what you can expect by 2030, the size can go 15 megawatt. This we are talking about the onshore wind turbine on the ground. Okay. And let us see about the offshore. Offshore current wind turbine size is 18 megawatt. Even you can Google it, you can search what is the larger size of wind turbine available today. So it will show around 18 megawatt, single size wind turbine. How much we can expect by 2030? This size can go up to 25 megawatt. Single wind turbine can produce up to 25 megawatt. What will be the blade size diameter? Can anyone see please? Difficult to read. I will read 350 meters. 350 meters. One football ground, how much meters? Anyone playing football, rugby? Around 100 meter, right? Football ground, rugby ground, around 100 meter. Okay. You know how much bigger it is, right? So it will be more than 3 times of that. Can you imagine how much will be 350 meters? So you have seen the football ground around 100 meter. So it will be 3 times of that. Can you imagine that will be the size of the wind turbine blades? Can you imagine how big it would be? And it will be placed on this tower. So do you think it will be easy task or very difficult task, right? And that too inside the sea. So you can see how fast this technology is growing and expanding. Okay. So, now here just to explain, it is very difficult to construct this wind turbine, commission this. Why we are going for the larger and larger size of wind turbine? You know very popular equation from the wind, half rho A V cube. Everyone aware of this equation? I think no one is left behind, maybe except these guys who are operating behind. Everyone will know that power available in the wind is half rho A V cube. All online student, I am sure that everyone is aware of this equation. Anyone knows sustainable, they know this equation, because this is the first equation. It will start on the wind. Anything you start with the wind, first equation it will come half rho A V cube, correct. So, here how the power available in the wind will depend. Rho is the air density, which is more or less constant. Then V is the wind velocity. Power will vary cube of the wind velocity. Obviously, we would like to have the wind power plants where there is very good wind velocity. No wind means no power. We will ask that how many years the cost will be recovered. So, the first factor we have to see what is the wind velocity, average wind velocity. It will depend upon that, like in how many years the cost of this commissioning of the wind turbine will be recovered. Okay. Payback period. So, it will depend upon obviously the how good is the wind velocity. If you place the wind turbine where there is no wind, the cost will never recover back. Agree? If you make the wrong decision where the wind velocity is very poor, so it will not be recovered. Do you agree? So, the wind velocity very important. The power produced will be cube of that. If there is little bit more wind, power produced will be cube of that. Then another factor what I am trying to explain, area. Area is pi by 4 d square. So, power produced will increase square of the diameter. If the diameter is say 10 meter, power produced will be square of that 100 units. If the diameter you double it 20, power produced will become 20 square 400. So, power produced goes from 100 to 400. The diameter you just double, power produced becomes 4 times. When we are going for the larger and larger size of wind turbine, so obviously the cost will also increase. Cost increase is more or less in the same proportionate. If you increase the size of the wind turbine twice, cost will just become double, but the power produced will be 4 times. So, you can clearly see that there is economy associated going for the larger and larger size of wind turbine. Someone can ask you why you are going for such a large size of wind turbine. It is very difficult. Okay. So, obviously economy is there. Clear for everyone? Excellent. So, this is like the trend what we are seeing for the wind. This is another the example of the small size wind turbine is very small, maybe smaller than what you call micro. So, this is like say very small size wind turbine 3 kilowatt, maybe can be installed on the rooftops of the building where there is a very good wind velocity. In fact, this picture coming from my exam in one of the PhD thesis for the Victoria University in Australia. So, the researcher explored the possibility of the small size wind turbine on the rooftops of the building. He explored the possibility in the Victoria state in Australia and Tamil Nadu state in India. So, what type of this wind turbine? Vertical axis, horizontal axis? Vertical axis. Okay. So, this vertical axis wind turbine, small vertical axis will have the less centrifugal forces as compared to horizontal. Okay. So, that will have less stress on the buildings. Okay. So, if this technology is commercially successful, in future we may see that like the wind, there might be large number of wind turbines also installed on the rooftops of the building, maybe along with the solar as well, where there is good wind velocity. Okay. So, now let us talk about the little bit about the photovoltaic system, which is the first keyword for our this GIAN program, right. So, let us see the importance of this photovoltaic. Here you see how much this sunshine we get from the sun on the earth surface, and if we see that how much power it can produce. So, this power that what we can get in terms of sunshine is of the order of 1.2 into 10 raised to power 8. This is coming from one of the very good book on the power system by GM Master, Renewable and Efficient Electric Power System. Have you heard anyone this book, GM Masters Renewable and Efficient Electric Power System? Very good book, even for the teaching purpose, and very good book. Okay? So, it says that the power from the sun, it can be this much amount. How much is this power? If you can use this power, whole power, just like for 1 hour. Okay. If you can use this all this power from the sun, what is coming on the earth surface, just only 1 hour. How much will be that power? That energy will be sufficient for the whole world for 1 year. So, you can see the potential of the power what is available from the sun is huge. If you can just tap for 1 hour, it will be sufficient for the whole world for 1 year. Use for 1 hour and sufficient for 1 year. You don't need any other type, coal, large hydro, nuclear, wind, you don't need anything else, just solar is sufficient, and you are using for 1 hour. This is the potential what you have got from the solar. Then you see the mode of generation of electricity. Okay. And we can compare with the other modes of electricity generation. Here with the solar, you place the PV panel just in the sunlight, it will generate the electricity, as simple as that. Okay. Of course, you keep at certain angle. How much is the angle roughly? The angle, how much angle we just keep? Any idea? Around 20, yeah? 20 degree? What is the angle at which we place the PV panels? Angle of the latitude. Approximately around 20 or something like that. Huh? Excellent. So, just place at the angle and sunshine is there and it will generate the electricity. If you compare in other types of plant, for example, coal, you have the coal from the coal mines. Coal mines coal will be crushed in coal based power plant. How much fine the coal size is there? It is very much fine like the talcum powder. The coal size crushed in the powder form, okay, and that coal will be burnt in the boiler. It will produce the steam. The steam temperature 550 degree and required pressure, okay, and even this steam, the steam being used, the term they call it like the dry steam, okay. So, because if there are moisture content in the steam, it can affect the turbine blades, it can corrode the turbine blades. The turbine blades extremely costly, and if the blades get corroded, replacing cost will be huge, okay. So, that the steam will rotate the wind turbine, then along with that you have the generator which will produce the electricity. How many stages you see for the electricity generation? Story is more or less same for any type of generation, right. So, coal is the power generation from PV, very much environment friendly, very much reliable, no moving parts, and complete silent operation. If you just stand very close to the PV panel, do you hear any noise? No noise at all. If you stand near to diesel generator, if you are talking on the mobile, you cannot hear anything else than the generator noise. And same is the story in the power plants, causing the huge noise. The operation and maintenance cost for the PV panel very low. Just what you have to do, just clean periodically the dust, okay. Depending upon the place where you are, just regular cleaning is required, but no oiling or greasing like that, just only cleaning of the, because dust will affect the efficiency, okay. And PV panels, PV systems can be installed very quickly. If you have other types of power plants, gestation period, how much time it will take? It could be of the order of 5 years, 8 years, like that. PV system, big size power plant, you can install and start generating electricity within 1 year time. It is very fast, okay. The issues, one issues used to be there, that PV system used to be very costly, but that used to be the situation few years earlier. Now PV is no more a costly. I will show in the coming slide about the cost. Of course, there is an issue of the intermittency. We understand, we respect, and then we find some solution for that, adding other sources, adding the batteries, adding the backup, okay. So, you can see that how much are the great benefits of the PV system. What about the fuel consumption? It is free, right. So, of course, one issue you see that efficiency of PV system is low, as I mentioned, but because fuel being free, it is not that as big concern. Engineers, scientists are working to improve the efficiency of material by combining, different material technology. Let us hope that in future efficiency improves further, because the solar PV technology is not matured. Okay, still you can say it is new technology. Okay, so here PV systems, you can have the photovoltaic systems. The size of PV systems, it could be very small size. How much small? Individual houses, just like 2 or 4 panels, okay, like 1 kilowatt for example, okay, or even smaller size. If you are doing some project, you can have this much of small PV panel, right? So it could be very small size of PV system, or it could be very big in terms of like your conventional power plants, or it could be medium size like on these university buildings, some kilowatts rating. So the size of PV systems could be very small, tiny to very big. How these PV panels will be mounted? If it is small size, placed on the rooftops of a building, sometimes you see small PV systems can be mounted on the pole, on the slides, okay. Or if the PV, when we are talking about the PV farms, then PV system will be obviously installed on the ground, okay. Here you can see the PV systems like grid connected PV systems. The grid can work as the backup for the PV systems. When there is power available from the PV, it can supply to the this house, of course through these converters. If there is excess power, it can fed to the grid through the net metering scheme. If there is no power or less power available from the PV, the additional required power will be supplied through the grid. So which is self-explanatory. Do I need to more, or is clear for everyone? I think straightforward. Huh? When we so this PV system could be connected with the grid, or the another option could be that PV systems can be in isolated mode. So when we have this isolated mode, then we need some kind of backup. Backup could be in terms of batteries, or there can be diesel generator as well. Then we talk about the like say another applications, like in the irrigation system, you can have these PV systems connected to the DC motor used for the pumping applications, like in the country like ours, agriculture based. So this could be another great application for the photovoltaic systems. One of the researchers, I recall, from BITS Planning in India, did the research about this PV application for the water pumping. Okay, so how this expansion or growth has taken place in the photovoltaic? You see, wind started around 1980s, mostly the power generation. Here PV, you can see that mostly PV started, you can see around 2008 or like that. And you see initially the capacity installation very less, because it was very costly. Okay. And in the recent years, you can see how exponentially the installed capacity is increasing worldwide. So PV started quite late as compared to wind. Now you can see end of the 2023, the worldwide PV installed capacity is more than 1600 gigawatt. Okay, it has already more than wind power system. The countries which are leaders in the power generation from the solar are China, US, India and Japan. Our country also doing really great from the solar. We are close to 100 gigawatt from the solar power generation, photovoltaic. So, what is the growth rate? If we see with respect of solar, around wind we show around 10%. Here growth rate for the in installed capacity is around 25%. Within a period of 4 years, the capacity is just doubled. Even within a 3 to 4 years, this capacity will be doubled. So, you can see that solar is expanding very fast. So, if we see that the larger size of power plant, for example, in our country, we have got the two big solar power plants, one in the Karnataka state, more than 2000 megawatt capacity, same in case of Rajasthan state. So, you see that these PV systems require the huge area. This 2000 megawatt PV system required an area of around 50 square kilometer. So, it needs the huge area as well. And then of course, it needs significant cost. The another great point I wanted to mention that our public utility NTPC, whose main business is in the power generation from coal and gas, but now they started diversifying their portfolio towards the renewables, expanding their renewables, and their energy mix currently 96% mainly from the coal and gas. They want to diversify their portfolio 70-30, 70% from the fossil fuel, 30% from the renewables. Then other countries also have the large size power plant. If in this, as I said, I visited almost all the power plants for this NTPC. If we have any power plant more than 2000 megawatt capacity, they will call the plant as the super thermal power plant. What they call it? Super, like big size. So, they call it super thermal power plant. So, here the point what I am trying to say, that these wind power plants, it is not just like what we are talking about the microgrid, but they are developed like the super plants. Their capacity you can see has expanded the PV farms, like not like this small size, but you can have a really big size of PV farms. Just imagine a PV farm 50 square kilometer area. Think of how big that area, 50 square kilometer area. In that you have PV plants. Can you imagine? 50 square kilometer area, in that you have PV plant. So, it will need huge area and this size will be really big. So, PV systems are now like, say, not like the only small, but they can have big plants. So, very small size, medium size and big size as well. That is also the flexibility with the PV system. This is the graph for the University of Queensland. I previously worked at the University of Queensland, Australia. At that time, we used to have 5 megawatt of PV systems installed on the rooftops. This I am talking around the year 2012. But now we can see that almost everywhere we see this PV system. Okay, even you will see here you have also PV plant. Okay, now this is not something new, but how fast is this PV system is expanding through this website. Through this website, you can find lot of interesting information from this website. What type of the technology is there, and several interesting information you can find through this website. Okay. Now, when you are integrating PV systems, what will be the integration issues? What are the size of the photovoltaic system? As I mentioned, photovoltaic system could be small size, medium size, large size. When your small size PV system, you will be interested in studying the issues like if there is moving clouds, how the power produced from the PV system will be affected because of the moving clouds. But when we have the large size power plant, as I give you an example in the previous slide, the plant is spread over 50 square kilometer area. So, in those size of power plant, we will be interested in studying the effects, like how it will impact on the stability of the power system. Because in the conventional power system, we have the synchronous generators, which will store the energy in the form of kinetic energy, half mv square. But now when you are adding the PV systems, so it means you are replacing the synchronous generators which are rotating one by means of the static PV generators. So, this stored kinetic energy is helpful in this sudden disturbance. For example, on the power system, if sudden load change is there, okay, on the power system, if there is sudden increase in 500 megawatt load, okay, and then how this sudden increased capacity for generation will be there. You have to increase the coal input, it will produce the more steam, but it is a mechanical process, it is time delay. Okay. But electrical system is not going to wait for that. So, whatever is the stored energy in the rotating generator in the form of kinetic energy, so sudden disturbance is taken care from this energy stored in the generator. That helps in maintaining the stability of the power system. So, when we are using the significant capacity of the PV system, so in that case we would be interested in studying that how the stability of the power system will be affected if we have the large size power plant. Another question will always come to the mind. For example, we have the large size PV system, whether we should have connected to the grid, whether we should have any storage system or not. If storage system is there, which way it can be beneficial. So, this is an example of University of Queensland. Here you can see that this is like the what you call say load demand curve, how the load is changing throughout the day. So, managing the peak demand is challenging task for the utility. If you have the storage system for the PV, so that stored energy can help the utility in managing the peak demand. So, this way storage system can be helpful. Okay. This is another great example from the University of Queensland in year 2000. The University of Queensland had their own 64 megawatt of solar plant. Having any university such a big size of power plant is really a great task. So, this 64 megawatt, how many panels, PV panels? 2 lakhs PV panels. So, now again one very interesting point it will come when we have this, always we are talking, sometimes the questions we have always in the background, whether the solar is really 100% environment friendly, wind is 100%, what will be the battery when its life is over, right? So, what waste it will create, whether they are really sustainable or not. So, this is like very good slide, recent one, and the link is given. So, here if we compare with respect of other wastes, waste coming from the municipal waste, waste coming from the coal ash, plastic waste, etc. So, this you see here 16, and if you project say until 2050, so I say after next 25 years. So, you can see, compare the waste coming from the municipal waste, waste coming from the coal, and you can see the waste coming from the PV module, right. So, it is comparatively can see very less. Okay. So, basically because nothing can be perfect. Okay. You will not see that the system will be perfect. Okay. So, you have to just compare in the situation. Okay, like our country situation in terms of power, basically by May last year, we had the installed capacity for 17 gigawatt, around 60% roughly you can say coming from the fossil fuel, 41% coming from the renewables. Even you see the figure I am taking 2023, so solar was 67, but when I try to show you the latest figure, it goes to 95. How fast is solar increasing? So, and then of course, this when we are saying 41%, it includes obviously the large hydro as well. Okay. So, our country really doing great. Okay. Previously, we used to always have the gap between the generation and demand. We always used to have the shortage 10%, 20%, gap. Demand is more, generation less. But now we don't have this kind of big issue. We are really doing great. Even our renewable energy share is also very good if you compare with respect of other countries. So we are quite good. Of course, we have to keep on improving. We need to reduce the coal share because of the obvious reasons, but it is quite great. Then you see the growth of the renewable generation, what we see from the different, it is just same what I explained, but little bit more, better way. Total what we have by September this year, we have the power generation from the renewables is 154. Let me go previous slide. So here we are including the large hydro, but in the here we have not included the large hydro. Okay. So this we are talking about the small scale renewable generation. Then I examine another PhD thesis from the Tamil Nadu state, Gandhigram. Have you heard anyone? Gandhigram, another university. This slide shows the how much potential we have got for the renewables in our country. This like the wind potential. When you make the potential for the wind, we will always seeing what height you are doing this potential for the wind, whether you are measuring at the height of 50 meter, 80 meter or 100 meter. So basically you can see that if you see at 100 meter, it has got the potential of like say 300 gigawatt, or even if we see around 80 meter, the potential is 100 gigawatt. How much we have explored? Just like say around 40 gigawatt. So we have got the huge potential for the wind. Same is the case for the solar, small hydro, biomass, tidal, OTEC. So we have got the huge potential for the renewables, and we expect to expand in renewables significantly. Now I examine another thesis from the same Gandhigram University. So some of the important key points I just added. It could be research questions, or very nice to see that. So as you see that renewable requires this significant land. I give an example of solar, how much land it needs for the large size power plant, and the land is really an issue, like for our country, highly dense, So basically how we manage with the lands. So I'm not going into the detail, but like say my apology, we are slight bit late, but I will try to cover up, because this slide I say is most important, and I really fully understand. Okay, I can pick up for the others. So here basically you can see that whatever the wind turbines we installed maybe 15 years earlier, their size used to be smaller size. Most of them would have almost about to complete their useful life. Okay. So what we can do now, we can replace those with the bigger size of the wind turbine. Okay. And in between free space, we can also place the PV panels as well. Whatever the free space available, we can place the PV panel. Not only that, we can also have the irrigation in the same place as well. Okay. So, having the multiple utilization for the same land. So, this is very much essential to have the optimal and multiple use of the land. Okay. So, this slide you can see whatever cost we used to talk for this wind and PV. Few years earlier, the cost for the wind you can see used to be around 6 rupees per unit of the electricity. Now this cost has decreased significantly. Now the cost has come down around 3 rupees per unit of electricity. The cost of the solar, you see how fast this start decreasing. Now we have the cost of this electricity generation from solar less than 2 rupees per unit, and this PV still it is not mature technology. Cost can come down further. Of course, this cost from the wind it may not come down because the technology is matured and we may not expect the cost down, but the cost of PV can go further down. Not much, but little bit decrease further as well as technology matures. So, now cost is no more an issue. So, our government plan, great plans what we have from our country. Our country has great plan, great targets. At least we should keep the target very high. So, our country plans to have renewables 500 gigawatt by 2030. And we expect to achieve net zero by 2070, and we expect that our growth will be there. Maybe so we try to achieve as much as we can. You can see how fast we have expanded in the solar. Okay. So this expansion is there. Now talking little bit about the microgrid, particularly hybrid power systems. This same name what you previously used to call like the hybrid power system. When people get bored, they will try to little bit change the name. Now microgrid looks more appealing, right? But you see similar. Of course, the hybrid it can be connected with the grid, it could be isolated, but when you see you are writing your thesis, so it will be lot of brainstorming what should be your thesis title. Initially you have title, then fine tuning, and you see what name it really is very attractive. Yeah. So I will maybe speak tomorrow, maybe when we have this another session related to that. I will maybe probably discuss more about that little bit later stage. Basically here we have already talked about the wind onshore, offshore, and then we have talked about the photovoltaic. There are other solar technology, but photovoltaic is the main one. Solar can have another applications, then some of the other renewables, what we are talking about the fuel cell, okay, that is also part of the course. I am not talking more about that, I am not expert in that, but it is little bit new technology. So at this stage may not be very commercially successful, but in the coming years like it could be commercially more successful. Okay, so that's hydrogen, batteries. So battery is the most dynamic technology what we have being used in the renewables, being used in the electric vehicles. So how we are doing, maybe a smart grid, probably we little bit, let me quickly cover up. So this smart grid has the three key aspects. One is the infrastructure. When we have conventional power plant, we have the generation, transmission and distribution. But with the renewables, then additional you can have this electric vehicles, vehicle to the grid, grid to the vehicles. Then here in the smart grid, there is more emphasis on the information and communication system. So how this smart grid will be managed, what will be the management objective, minimization of emissions, minimization of losses. There will be multiple objectives. How this smart grid will be managed using the conventional programming, intelligent programming, PSO, machine learning, game theory, AI, but not ChatGPT, right? So there are so many tools, technique coming up. Then the protection of the smart grid is another great topic. And then of course, maintaining the security and privacy of the data is extremely important, because through the use of smart meter, lot of data will be used. How this the security and privacy of the data is maintained. So here, how we are moving from the conventional grid to the smart grid. Basically, we have got the centralized generation. Then what we need the centralized generation plus distributed renewable generations. Electric vehicles are likely to come. How it will impact the grid. Power flow becomes bidirectional, and there is two-way communication through smart meters. The customers can utilize their energy bills through the smart meters, and this smart grid expected to have the self-monitoring and self-healing properties. At the end, which way customers get benefited? I ask you one question. Can you recognize this electricity, whether it is coming from the conventional power plant or renewable? I think we cannot recognize, right? So for the common person, it doesn't bother much whether the power is coming from the coal or power is coming from renewables. They will be interested in the cost and of course the service. Okay. So they want to see the quality of service and the cost. Okay. So what we expect at the end, the customers expect to have some choice. There should not be only one utility in the same area. If their service is not good, at least we have 2 or 3 utilities. There is healthy competition, so that customer can get the electricity at the competitive price, and customer has choice. Okay. So I worked previously in Australia. So if you are unhappy with the one utility, on phone you can switch over to the another company. They will give you some rebate as well. Okay. So basically, this is what it is expected in the smart grid. So here you see in smart grid different components what you have, how we are generating electricity through conventional power plants. They are there. Then renewables, wind, PV, storage, electric vehicles, buildings. So this all forms the smart grid. Then in smart grid, as you see that there is emphasis how the power flows, how the the communication system is there, how information flows. I give you an example. For example, we have the electric vehicles. If you want to feed power from electric vehicle to the battery, then you should have, then system should know what is the status of your battery. Okay. So all these, the communication system is extremely important here in the smart grid environment. So the I supervise large number of PhDs, postdocs. The researchers contribute significantly in publications, contributing in terms of books, different areas close to the power system, protections, distributed generation, renewable technology. Even one researcher worked on the how to improve the efficiency of coal-based power plant, power electronics drives and applications, renewable technologies. So this reference I was mentioning, this is very good book talking about the renewable and efficient electric power system. Really very nice book. First edition came in 2004 and then second edition it come in 2013. I think 2004 you can freely download freely downloadable, and there are several interesting references. So this is all from my side for this chapter. So I will just stop here for few minutes and then we will continue for the next session.